All right, I'm going to talk to you guys about a few of these. Number 6 in particular isn't terribly difficult to get right, but sometimes I have students kind of misunderstand what's going on. So whenever you're given these tables with selected values of x and then selected values of the first and second derivative, you're going to want to use the second derivative test to find the maximum, not the first derivative test. Because if you tried to use the first derivative test for both of them, 2 is a critical number and 8 is a critical number. If you're looking and you say, okay, the first derivative doesn't change sign, then there's not a max or min. You don't know what's happening between 0 and 2 or what's happening between 2 and 4. And same thing here. We don't know what's going on between 6 and 8 and 8 and 10. We don't know that those are the only 2 critical numbers. So it's super, super important on ones like this that you use the second derivative test. And so the second derivative test tells you if we have a critical number like we do, and the second derivative is negative, that means that the function is concave down, which is going to create a relative maximum there. Right? And then for this one, 8 is a critical number. The second derivative is positive, so that means that this function is concave up, which is going to create a relative minimum. So the answer choices are in the way that number 2 is the only one that's true. All right, so very easy to make a mistake on that problem. But try your best to remember that you're going to want to use the second derivative test. Okay, and then the other 2 I want to talk about were 9 and 10. Just the way the snow days felt, I don't feel like we got enough time to really practice talking about these graphs and the relationship between the first derivative and the original function. So on number 9, we have the graph of the first derivative. We want to figure out which function could be that graph. So try to remember as much as you can, wherever the first derivative is positive or graphed above the x-axis, means that f should be increasing. So that can help you narrow it down. So that's going to be between 0 and 2, and then again between 3 and 4. And when the first derivative is below the x-axis, then f is going to be decreasing. So that is going to be between 2 and 3. Right? And sometimes that's enough for us to get the answer, but not necessarily on this one, because C and D both fall into those categories. So we're going to have to go to something new that we learned about the first derivative and the concavity. So when the first derivative is increasing, then f is concave up. All right, so it looks like the first derivative is increasing between 0 and 1 and between about 2.5 and 3.5. And then where the first derivative is decreasing, f should be concave down. All right, and that is going to be between 1 and 2.5 and between 3.5 and 4. Okay, so if we narrowed it down to C and D, hopefully using the concavity, we should be able to narrow it down between those 2. Okay, so we're looking for concave up and then concave down and then concave up. So that has to be C, because at the beginning of the graph, on D between 0 and 1 is concave down, and we want it to be concave up. Okay, so be careful. This can get tricky. It's a lot to remember. All right, and then D. D is the opposite. So we have the graph of f, and we're trying to match it with the derivative. So when f is increasing, we're just going to work in reverse, then f prime should be above the x-axis. And so I don't have markers, so it's like for the x's, but we can make them if we wanted to, but I think we can figure it out without that. And when f is decreasing, sorry, f prime should be below the x-axis. Right, so that actually pretty much will get us the answer. We could also talk about concavity. So when f is concave down, so this section right here, f prime should be decreasing. When f is concave up, f prime should be increasing. And then where there's a point of inflection, f prime should have a relative max or min. And all of those correlate with B. And I'm going to write that down because the one on your test might be harder and you might need that. So concave up, when f is concave up, these are all f. F prime is decreasing, f concave down, f prime in. Oh, I read that backwards. Sorry. Concave up, f prime is increasing. Concave down, f prime is decreasing. Point of inflection, f prime has a max or min. Right. Okay, study those flashcards and don't just memorize the flashcards. Like, think about what it means for the graphs. Email me if there's another one you guys want me to do. I'll be here till 4:10, so after that, I won't be checking my email.